So this is your ear. Okay, so this is the auricle of your ear. Okay, the auricle of your ear has a super important function. If you do this, you'll understand what the function is, especially if I'm still talking, because it funnels the sound waves into your ears. Okay, so it's actually a very important function for your auricle. So your auricle funnels the sounds into your ear. This is going to be your outer ear, right, or ear canal. This is where you put your Q-tips that you're not supposed to, right? And so you'll notice that there's a bone. Do you see the bone here? Okay, that's the temporal bone, right, where the opening would be the external acoustic or auditory meatus. Okay, so that's what you're putting your Q-tip into. If you ever feel bone around there. Okay, all the way, and hopefully you have never gotten all the way to your tympanic membrane, which is your eardrum. Remember, this is filled with wax, and the wax helps the tympanic membrane stay nice, supple, and soft. Okay, that's what your wax is for. So this is your tympanic membrane, or your eardrum. Oops, sorry. Eardrum. Okay, your eardrum, what's gonna happen is as the sound waves come in, your sound waves are like oscillations. They're like waves in the air, which of course you don't see. They're not visible, right? But what they're going to do is they're going to kind of go into your ear. And their oscillation is going to be measured by something called hertz, right? That's the unit of measurement of sound waves, okay? So depending on the hertz, okay, this is going to vibrate, okay, at a certain hertz. That vibration is then going to be transmitted to the bones of your middle ear, okay? So this is going to be, so this area right here is the middle ear, right inside of the tympanic membrane. Right here is the middle ear, okay? And so the three bones of your middle ear are the malleus, which is right attached to the tympanic membrane, the incus, which is kind of anvil-shaped, and then this right here, which is the stapes. Okay, so that little thing right there is the stapes, okay? Which is also called the stirrups. It kind of looks like a stirrup. Okay, so these three are kind of attached. Okay, so then in this middle ear, you're also going to have a tube, which is called the pharyngotympanic tube, also called the auditory tube, but it goes from your throat to your middle ear. Okay, so in children, this is very big. Okay, so it's very wide. It hasn't adjusted and become narrow yet. So that's why kids get a lot of inner ear infection or middle ear infection. Okay, because they get a throat infection and it goes up their tympanic membrane into their middle ear, which then can go into their inner ear, which could be really, really bad because that can cause damage to this structure, which is now located on your inner ear. So from here, this is from your middle ear, and then all of this structure is going to be located in your inner ear. So notice that it's in the bone. Okay, this bone is the temporal bone. It's the petrous portion of your temporal bone, so that's that thick little ledgy part of your temporal bone on obviously the middle. It's like the bottom of the middle cranial fossa of your skull. Okay, so this little structure here is called your cochlea. Okay, and then you also have the semicircular canals. These detect the semicircular canals and the vestibule, which is this area right here, that detects movement, right? Balance. It's your balance detectors. There's two parts. The vestibule area, which is this area right here, that is going to take care of something called linear acceleration, which is when you're moving forward. Okay? And then your semicircular canals are going to take care of angular acceleration, right? When your body's going at an angle. Okay? So I think I talked last time about cerebellum and about gymnasts who can do backflips onto a 4-inch wide beam, which is about that buck, the balance beam, which I find every single time I see it, I'm like, props to you, because I can't even walk in a straight line. So when they're walking, flipping backwards, they have a very highly developed, right, sense of balance. So their semicircular canals are probably fantastic. Okay, so semicircular canals can detect when your body is moving in an angle, so they can kind of adjust. It tells your cerebellum where your body is, so that you know where you put your feet. And if you've ever done a backflip and didn't land on your legs because you had have communication between your middle ear, or your inner ear, and your cerebellum. Okay, so this does balance. Okay, that's all balance. And then this is going to do hearing, which is called the cochlea. Okay, so the cochlea has different layers, if you want to call them. Okay, they have different layers. Inside the cochlea, if you were kind of to undo, because you see it's kind of curly, if you were to undo this curl right, there's a membrane inside that's called the basilar membrane. And remember I told you that your sound waves are different hertz, which just means the different oscillations, right? How big and how, far apart they are. They are going to then take this membrane and go whoop on the membrane. So the membrane will deviate at whatever hertz it is, okay? So then that'll be transmitted into your cochlear nerve, okay? And then from your cochlear nerve, it'll go to your auditory cortex in your temporal lobe of your brain, right? And this is your vestibular nerve, which is coming right from here. So vestibular nerve, cochlear nerve, they come together to form the vestibulocochlear nerve, which is cranial nerve number 8, which is all sensory, senses, balance, and hearing. Yes?
So when you're dizzy, when you get dizzy...
Do you know when you spin around and then you fall to one side? What you've done is in the semicircular canals, there's gel. And the gel all goes in one direction, and that's why you always fall in the direction that you've been spun. So do it next time. Take a chair. And those cheap chairs are great. Just make sure that you're, away from any desks and stuff. Spin in one direction, stop, see which way you turn, then sit back on it and spin the other direction. You'll see you'll fix it.
I know when you flip, you tend to flip, try to get my balance.
Yeah.
Like.
Right, you're falling in the direction usually of your, yeah.
So that's.
Yep.
Where it is.
You want to do it?
For the video.
No, get further, get in the middle. Please get over here, so he's not away from the point of demonstration.
Somebody speaking.
You do with the feet. Okay.
This is Pete demonstrating angular acceleration. Demonstrating angular acceleration. Excellent, excellent. So you fall in the direction that you spun.
9.75.
Yes, the gel. There are these things called cupulas, and the little cupulas will go whoop, all in the same direction, and then it's telling your body to go in that direction. They're all going in one direction, so you're going in the direction of wherever they're going. All right, so
Wonderful.
I'm done. Happy Thanksgiving.
Happy Thanksgiving.
Thank you.